Alright guys, so what we're going to do now is 8.6, and this is solving equations with radicals. This is a very important concept that you need to make sure and get, especially before you go into college algebra. So, a radical equation is an equation, and it should say that has a variable and the radicand. So an example of this is the square root of x plus 1 equals 3, or 3 square root x equals the square root of 8x plus 9. Another example of this could be like 1 plus the square root of x plus 1 equals 3. So this is another example where you have a radical equation. Alright, so how you solve radical equations. The first thing that you have to do is you have to isolate the radical. And you always isolate it if you have addition or subtraction going on. So if there's anything attached with addition and subtraction to your radical, which is just your square root, that's where you have to make sure and isolate the radical. So like right here, there is nothing that is attached with addition or subtraction with the square root. And right here, this is multiplication, which is totally fine. And there's nothing with addition and subtraction. But then this last one right here, we would have to isolate the radical because we would be adding 1 on both sides. So what we do first is we subtract the 1 on both sides. So we isolate the square root of x plus 1 equals 2, because 3 minus 1 is 2. Alright, so arrange the terms so that the radical is by itself on one side of the equation. Step 2 is you're going to square both sides, so you're going to go parentheses squared equals parentheses squared. Step 3, you're going to solve the linear equation or the quadratic equation. So you might want to get out your factoring is fun worksheet from chapter 6 that is left behind. And then step 4, this part's very important, is you must check you must show by checking your answer. Okay, if you don't show this step, it's going to be half off. Okay, so please make sure that you check your answer. So first thing, isolate the radical. Second thing, square both sides. Then you solve the linear or quadratic equation that's left behind, and then the last thing you do is you check your answer. Okay, so let's make it real. So first thing we gotta do is read the problem. So we got the square root of x minus 5 equals 6. First thing we gotta do is see if the radical is isolated. So there's no addition or subtraction, so that part is done. Step 2 is we have to square both sides. So we're gonna go parentheses squared, parentheses squared. So what happens is squares and square roots are opposites of each other. So we're just left with on the left x minus 5 equals, and 6 times 6 is 36. Okay, now after we square both sides, so we have to solve. It is a linear equation because I just have an x. The way that I know it's quadratic is if I have an x squared. So in order to get x by itself, I'm going to add 5 on both sides. So I get x equaling 41. The last thing I have to do is I have to check my answer. So I have to plug this into my original problem. So I come back up here and I go the square root of 41 minus 5 equals 6. 41 minus 5 is the square root of 36 equals 6, and the square root of 36 is 6, so 6 equals 6. Those are the same numbers, so that means this answer is 100% correct. Okay? Next problem, we have the square root of x equals negative 4. So first thing I have to do is check to see if my radical is isolated, so it's not with any type of addition or subtraction, so step 1's done. Step 2 is we have to square both sides. So when we square both sides, those are opposites of each other, so I'm just left with x. And then the square root of 4 squared, square root of 4 times square root of 4 is positive 16. So I get x equals 16. Now, I don't have to do any solving because x is already by itself, so now I just have to check my answer. So I go back to my original problem and I go to the square root of 16 equals negative 4. Square root of 16 is a positive 4 though, and positive 4 does not equal negative 4. So since this answer is false, my final answer is empty set. So you can either put the symbol notation for empty set, you can write out empty set, or if you want to put no solution, you can do that as well. Any one of those 3s would completely work for me. Alright, let's look at the next one. So we got 4 square root x equals square root of 10x plus 12. So first thing I want to do is I want to isolate the radical. So since this is multiplication, it's totally fine. It's only when it's addition or subtraction when we have to do anything to it. So step 1 is done. Step 2, I'm going to square both sides. Now this is a place where people make this mistake. You have to make sure and apply it to both parts. So you have to go 4 squared, which is 16, and then the square root of x squared is just x. So I got to make sure and put it to point A and point B, or part A and part B. Alright, and then right here I'd be left with 10x plus 12. Okay, so next thing I got to do is I've got to solve. It's still linear because it's just x, so I'm going to subtract 10x on both sides. I'm going to be left with 6x equals 12. Got to get x by itself, so I'm going to divide both sides by 6, and I get x equaling 2. So we're not 100% sure if this answer is correct, so we got to check our answer. So we plug it back into our original equation, so I got 4 square root 2 equals the square root of 10 times 2 plus 12. Alright, so I got 4 square root 2 equals 10 times 2 is 20, so I got 20 plus 12. So 4 square root 2 equals the square root of 32. Now I don't see that they're the same just yet. So what I need to do is I need to simplify this 32. So that would be 1 and 32, 2 and 16, 3, nope, 4, 4 and 8, 5, 6. Alright, and I think that's it. So then I'm looking at my largest perfect square, which would be 16. So I've got 4 square root 2 equals the square root of 16 times 2. When I pull out the square root of 16, that would be 4 square root 2. Those two are equal to each other, so then I can come and I can box my answer. Make sure that you show this step. If not, it's going to be 50% off. Okay? Now I want you to try. So pause it and work through this problem, please. Alright, so we got the square root of 3x plus 9 equals 2 square root x. First thing I want to check for is that I have my radical isolated. There's no addition or subtraction. There's multiplication, but that's okay. Second thing I'm going to do is I'm going to square both sides. When I square both sides, it lifts the radical, so I got 3x plus 9 equals, I got to apply it to both parts, so 2 squared is going to be 4. Square root of x squared is going to be x. This is linear, so I'm going to subtract the 3x on both sides. And I get 9 equals x. I'm not done though, I have to check my work. I go back to my original equation, so I go 3 times 9 plus 9 equals, I don't know why I made that so long, 2 times the square root of 3. Alright? 3 times 9 is going to be 27 plus 9 equals 2 square root of 3. 27 plus 9 is 36. Oh, Rachel, I made a mistake. Right up here. I plugged in the wrong number. It should be a 9. Okay, so when I plug in that 9, square root of 9 is going to be 3. So 2 times 3 is going to be 6. Square root of 36 is 6. 6 equals 6. Hopefully you did it a little bit better than I did. We did get the right solution, but made a silly mistake. Make sure that whatever you get right here, that's what you plug into your original answer. I think I was just trying to rush it through my head. Alright? Now, I know this one says now you try, but I want to actually work on this together because you haven't seen one like this yet. So, I've got x, or at least started off with you, x equals the square root of x squared plus 5x plus 10. First thing I do is isolate the radical, so is there any type of addition or subtraction? With my square root, there is not, so the second thing I do is I square both sides. So I've got x squared equals x squared plus 5x plus 10. Alright, now I've got an x squared on both sides, so what I'm going to do is I'm going to subtract x squared on both sides, so I'm going to be left with 0 equals 5x plus 10. So even though it looked like it was going to be a quadratic equation, it ended up being linear because you got to subtract it on both sides, and once you do that, it cancels it out. So now from here I want you to solve it. Alright, so I'm going to subtract 10 on both sides. So I got negative 10 equals 5x. Divide by 5. So I get x equaling negative 2. So I have to check that, so I plug it back into my original equation. So I got negative 2 equals the square root of negative 2 parentheses squared plus 5 times negative 2 plus 10. So I got negative 2 equals the square root of 4 minus 10 plus 10. So negative 2 equals the square root of 4. Negative 2 equals 2. That is not a true statement, so I can either put empty set, I can write out empty set, or I can write out no solution. But I gotta make sure and see that work. Okay? That is why it's super important for you to check your answers. Okay, so now here's a trickier problem that you'll see because you actually have to do step 1. So the first thing we're going to do is read the problem. So we have x equals 1 plus the square root of 2x minus 3. So the first thing you have to do is isolate the radical. So you see how there's an addition of 1 on the square root side. So what we have to do is we have to subtract the 1 on both sides. So we get x minus 1 equals the square root of 2x minus 3. The next thing that we have to do is we have to square both sides, because that's step 2. So what we have here is we have a binomial. Sometimes it's easier just to write it out, so x minus 1 times x minus 1, so that you can see to FOIL it, equals 2x minus 3. So sometimes it's just easier to write out that way. So if we FOIL, x times x is going to be x squared minus 1x. Negative 1 times x is negative 1x. Negative 1 times negative 1 is plus 1 equals 2x minus 3. If I clean this up, this would be x squared minus 2x plus 1 equals 2x minus 3. Now if I look at this equation from here, I see that it's not going to be linear, it's going to be a quadratic because I have the x squared. So what I need to do is I need to bring everything over to one side so that I can use my factoring as fun worksheet. So what I'm going to do first is I'm going to keep the x squared exactly where it is, and I'm going to bring everything else over. So I'm going to subtract the 2x on both sides. So I got x squared minus 4x plus 1 equals negative 3. Then I'm going to add 3 on both sides. So I got x squared minus 4x plus 4 equals 0. So now I can use my factoring as fun worksheet. Whenever I have 3 terms, remember it can either be a equals 1, a does not equal 1, or it could be a perfect square trinomial. For perfect square trinomial, the first and the third have to be perfect squares, and the middle has to be even. So I'm going to test that theory. So we take perfect square trinomial. So I take the square root of x squared, which is x. I take the square root of 4, which is 2. Then I got to check it, so I go 2 times x times 2. It's always going to be that 2, remember? So 2 times 2 is 4x. So what this means is I have my binomial squared. And since this checks out, it's going to be x minus 2. And I have to continue to solve this, so I need to go x minus 2 equals 0. And there's no reason to write it twice because you'd be writing the exact same thing twice. So I'm going to add 2 on both sides, so I get x equals 2. The last thing I have to do is check my work. I'm going to check it back with my original equation. So wherever I see x, I'm going to plug in a 2. So we're going to let x equal 2. So 2 equals 1 plus the square root of 2 times 2 minus 3. 2 equals 1 plus 2 times 2 is 4 minus 3. So 2 equals 1 plus the square root. 4 minus 3 is 1. So 2 equals 1 plus 1. 2 equals 2. That absolutely checks out. I come over and I box my answer. Now, if you wanted to do an a equals 1, you would have still gotten the same answer. You just would have had it written it twice. But yeah. So that's a trickier problem you have to see because you first have to isolate the radical and it ends up being a quadratic equation. Alright? So I actually want to practice another one like this, so I don't want you to work this one for me. I want you to change it up just so we can have a little bit more practice. So here is the square root of 8x plus 8 minus 1 equals 2x plus 1. Okay, so that's the problem that I actually want us to work. So step 1, we have to make sure and isolate the radical. So this is subtracting with the square root, it's minus 1, so we have to add 1 on both sides. So we get the square root of 8x plus 8 equals 2x plus 1 is 2. Step 2 is we have to square both sides. So we get 8x plus 8 on the left, and then we're going to do 2x plus 2 times 2x plus 2, and we're going to FOIL that. So we got 8x plus 8 on the left. 2x times 2x is going to be 4x squared. 2x times 2 is going to be plus 4x. 2 times 2x is going to be plus 4x, and then 2 times 2 is going to be 4. When I clean this up, that's going to be 8x plus 8 equals 4x squared plus 8x, because I combine my like terms, plus 4. Okay, I see that it's a quadratic equation, so that means I need to bring everything else over. So what I'm going to do first is I'm going to subtract the 8x on both sides, so I'm left with 8 equals 4x squared. Those cancel each other out, plus 4. Then I'm subtract 8 on both sides, and I'm left with 0 equals 4x squared minus 4. Okay, now I've got two terms. So whenever I have two terms, there's two ways to approach it. It could either be a GCF or it could be a difference of perfect squares. And either way completely works. I'm going to start off by doing a GCF just to make it a little bit simpler. So if I pull out a GCF, I can pull out a 4. So 4 times x squared minus 1 would be what I was left over with. And then from there, the x squared minus 1 is a difference of perfect squares. So I would take the square root of x squared, which would be x, the square root of 1, which would be 1. So I got 0 equals 4 times x plus 1, x minus 1. But if you wanted to do it right up here as a difference of perfect squares, you would take the square root of 4x squared, which would be 2x, and then the square root of 4, which would be 2. So then you would have 2x plus 2, 2x minus 2. But then right here you'd have to pull out a GCF. So this would be 2 times x plus 1, 2 times x minus 1, and then 2 times 2 would be 4. So you would get the exact same result. I think it might be easier to pull out a GCF first when you approach a problem. Okay, but we still haven't solved it. We got to go 0 equals x plus 1, 0 equals x minus 1. Alright, so we subtract 1 on both sides, so we got negative 1 equals x. Add 1 on both sides, 1 equals x. And this time we have 2 that we need to check. So we're going to first let x equal negative 1, then we're going to let x equal a positive 1. And we're going to plug it into our original problem. So we got the square root of 8 times 1 plus 8 minus 1 equals 2 times negative 1 plus 1. So this would be the square root of negative 8 plus 8 minus 1 equals negative 2 plus 1. 8 minus 8 is, or negative 8 plus 8 is going to be 0, so all I'm left with here is the square root of 0 0, so that's negative 1, and then negative 2 plus 1 is going to be negative 1 as well. So my answer of x equaling negative 1 absolutely works. Now we got to check it for x equaling 1, so I take the square root of 8 times 1 plus 8 minus 1 equals 2 times 1 plus 1. So 8 times 1 is going to be 8. So I get the square root of 8 plus 8 minus 1 equals 2 plus 1. So 8 plus 8 is 16, so I get the square root of 16 minus 1 equals 2 plus 1. I could have cleaned that up. Square root of 16 is 4 minus 1 equals 3. 4 minus 1 is 3 equals 3. Those two check out. I come and I box my answer. Okay? So this is definitely a trickier problem, but again, since you see that you have a quadratic, that you need to make sure and bring everything over to get it equal to 0. Alright, so now what I want you to do is I want you to pause it and I want you to try to work this one for yourself. Alright, last problem that we have is we have x plus 9 equals 3 square root x plus 13. So first thing we gotta check for is that we isolate the radical, which we don't need to because it's multiplication. So we're gonna square both sides to go to step 2. So I get x plus 9 times x plus 9 equals 3 squared, which would be 9 times x plus 13. Okay, so on the left side I have to FOIL, the right side I have to distribute. So x times x is x squared, plus x times 9, 9x, plus 9 times x, 9x, plus 9 times 9, which is 81, equals, now we got to distribute the 9, so this would be 9x plus 117. Combine our like terms, so we have x squared plus 18x plus 81 equals 9x plus 117. I see that I have a quadratic equation, so I have to bring everything else over. So first thing I'm going to do is I'm going to subtract the 9x on both sides. So I get x squared plus 9x plus 81 equals 117. Then I'm subtract 117 on both sides because I got to get that 0. And I get x squared plus 9x minus 36 equals 0. I have 1, 2, 3 terms, so it either can mean a equals 1, a doesn't equal 1, or it could be a perfect square trinomial. This is definitely an a equals 1. So first thing I do is I set up my binomials. X plus minus, factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Okay? I know I have to use subtraction to get to my b, which is a positive 9. So the only one that works with that is the 3 and the 12. And it needs to be 12 minus 3. So my 12 has to be positive, my 3 has to be negative. So I got 12, or x plus 12 times x minus 3. So I split them up, x plus 12 equals 0, x minus 3 equals 0. Then I solve, subtract 12 for the first part, so x equals negative 12. Add 3, x equals 3. So now what I got to do is I got to check these answers, my last step. So let x equal negative 12. Then we're going to let x equal a positive 3. We plug it back into the original equation. So I'd go negative 12 plus 9 equals 3 square root negative 12 plus 13. When I clean this up, negative 12 plus 9 is going to be negative 3 equals 3 and the square root. Negative 12 plus 13 is going to be 1. So I got negative 3 equals the square root of 1 is going to be 1. 1 times 3 is 3. That does not work. So right here would be no solution. Or empty set. Okay, so this answer cannot work. But we still have to check for x equaling 3. So I go 3 plus 9 equals 3 times the square root of 3 plus 13. 3 plus 9 equals 3 times the square root of 3 plus 13 is 16. So 3 plus 9 is going to be 12 equals 3. Square root of 16 is 4. 12 equals 3 times 4 is 12. That one does work. So I had one solution that did not work, and I had another solution that did. So it's super important for you to check your work. If you don't check your work, that's going to be 50% off. Alright guys, this section is super important, so I need you to go and do your 8.6 homework now, and make sure that you show all work, make sure you check your answers. If you don't, it'll be 50% off for that homework assignment. And if you have any questions, please make sure that you bring them to class. Thank you.